Very well, guys. So, if you wanted to summarize the discussion in the previous video, what you will say is that we have five different variables in problems with acceleration: displacement, time interval, initial velocity, final velocity, and acceleration. And that for each of these, you have a given equation. We just saw that equation number one was an equation that said acceleration is equal to final velocity minus initial velocity, all of it divided by time. And so you can see that in that equation the displacement has no role. But on the other hand, the second equation didn't include acceleration at all. So the idea is that that equation was displacement divided by time is equal to initial velocity plus final velocity. In both cases, there was a missing variable. In case number one, you couldn't find out about the displacement. In equation number two, you couldn't find out about acceleration. Today, we will set the goal of actually finding a third equation in which, for the time being, our interest is what will happen if in a given problem they didn't give you the final velocity. If you don't know the final velocity, how could you possibly get any other thing? So, just to recapitulate, you want an equation, we will call it equation number 3, that includes the variables displacement, time interval, initial velocity, and acceleration. And our question is, what will be the shape of a formula like that? Well, interestingly enough, this formula can be obtained simply by combining the other two. And that's gonna be true for everything we do in this topic. You have the two basic formulas, and using those two basic formulas, you can find numbers 3, 4, 5, etc. So what is your first formula? Acceleration is equal to final velocity minus initial velocity divided by time. And your second formula, sorry about that, is displacement divided by time is equal to initial velocity plus final velocity divided by 2. Now, you want to get rid of the final velocity. So, in this particular case, for equation 1, acceleration times time is equal to final velocity minus initial velocity, and therefore initial velocity plus acceleration time is equal to final velocity. And in the second case, twice the displacement divided by the time is equal to the sum of initial and final velocities. Or in other words, twice the displacement divided by the time minus the initial velocity is equal to the final velocities. So you can see that what we have actually done is to isolate the final velocity in both cases, so that as it is not difficult to figure out, we can use the transitive property of equality if this expression that I'm highlighting in green is equal to final velocity, and this other expression is equal to final velocity, one way to get rid of the final velocity is simply to make these two things equal to each other. Therefore, initial velocity plus at is equal to twice the displacement divided by the time interval minus initial velocity. Now, if we were only interested into getting this formula, we will be done. But right now, we want to write it in a nice form. So let's say, for example, that you add similar terms. Twice initial velocity plus at is equal to twice displacement divided by time. And now divide by 2, multiply times the time, initial velocity time plus 1/2, remember that you're dividing by 2, acceleration time squared. You are multiplying the time on both terms, times vi times t. And so that's equal to the displacement. The usual form in which we find this formula then is that the displacement of an object that is accelerating is equal to the product of its initial velocity times the time plus 1/2 acceleration times the time squared. And that we will baptize as equation number 3, and it's something that is worth a red rectangle. So that's it for this video, and I hope you enjoyed it. See you.